Context-based access control, or like his friends call him, CBAC, with IPv6. In this MicroNugget, we're going to take a look at implementing stateful firewall services using CBAC on a Cisco router. Let's begin. Our objective for you and I in this MicroNugget is to take a look at the world of context-based access control, or CBAC, to identify exactly how it works, how to configure it, and how to verify it. The objectives of context-based access control are this. We want our internal users here to be able to go out to the internet. So what does this user want? Bob, for example, when he goes out to google.com, he's expecting a web page to show up. So with context-based access control, we're going to allow the return traffic as well. Now you might be thinking, Keith, that's just basic networking. You send a request, you get a reply. However, what we also want to have happen with context-based access control is this. If there's an external system on the internet that's trying to initiate a brand new connection, we don't want that user on the outside world to initiate a connection to Bob, like an attacker doing a port scan or ping sweep or something else. So we want to deny all of that traffic right here at the router. So the best of both worlds is clients on the inside can go out, reply traffic can come back, but outside resources cannot by default initiate inbound connections. That, my friends, is the primary concept behind context-based access control. To achieve this, we're going to use two specific techniques. Number one is an access control list for filtering. Now, that's really not new. We've done access control lists for decades, and an access control list would go something like this. We want to permit virtually nothing on this outside interface if it's trying to come in. So we create an access list that's very restrictive when we apply it. Now, all by itself, that access list is a big problem for Bob. Because if Bob is trying to go to the internet to Google, the reply traffic is coming back, oops, this ACL is going to kill it. That's where the magic and the power of context-based access control comes in. The second step is we're going to inspect the traffic. Now, when we see the word inspect, I want you to think remember the traffic. We're going to train R2 to remember, for example, TCP sessions that are sourced from users over here as they go out to the internet. Now, why is that important? If this R2 router can remember that Bob is initiating a connection from his IP address and is going to this Google server or some other server at port 23, if it can remember that session information, when the reply comes back, this is the magical part, when the reply comes back, even though there's an access list that otherwise would say deny it, if that session is remembered in the memory of R2, R2 will dynamically allow that return traffic in spite of the access control list that's present. So two basic parts. Number one, we have an access control list for filtering. That's the policeman. And then we have the inspection rule of context-based access control that's keeping track of sessions to allow reply traffic to come back in. To implement this, it's a two-step process. We're going to apply an access list. We're going to create an access list and apply it on the gig 2/0 interface of R2. So this access list is going to permit protocol 89, which happens to be OSPF, because I don't want any OSPF neighborship to break between R2 and R3. But besides that, there's an implied deny at the end. So virtually all other traffic is being denied other than OSPF. Just as a side note, the end of an access control list in IPv6 also implicitly allows for the neighbor discovery protocol. But other protocols like TCP and so forth are not going to be allowed inbound on this interface. So at this moment, all the traffic that's trying to go from our trusted networks to the external networks, the reply traffic coming back to our users is going to be denied by this access control list. Well, I shouldn't say yet, because we definitely want to apply this access list to the interface. Let's do that right now. To apply the filtering access list to the interface, we need to go to interface configuration mode and say IPv6 traffic filter, the name of the access list, and then the direction. So in effect, we're telling the router, hey, any inbound traffic trying to come in on gig 2/0, you check the access list. If it's not on the permit list, go ahead and deny it. In this case, we're only allowing OSPF. The second part of configuring context-based access control is to create an inspection rule so that the router can take a look at traffic going from our internal networks to the external networks and remember those sessions. Now, in our example, I'm going to create a very simple inspection rule, and all we're going to look at, all we're going to inspect is TCP traffic. We're not looking at UDP or ICMP. So effectively, this inspect rule, once we apply it, is going to be looking for TCP-based sessions to remember that information in its stateful database. Just like the access control list that we created wasn't really working until we applied it to an interface, the same is true for an inspection rule. Because we want R2 to analyze all the traffic that's going out of gig 2.0, because that's coming from our users going out to the internet, we want to go ahead and put our inspection rule on that interface. So in interface configuration mode, we simply apply the inspection rule and we tell it which direction to pay attention to. Outbound would imply all traffic that's trying to leave that interface, which also implies it was coming from our internal users. Now, how do we verify? I'm a big believer in verifying our configuration as we go. So let's do a show IPv6 inspect, just the configuration portion. And it's going to show us all the details. And here we have this rule called our CBAC rule. And it says TCP inspection is on. I didn't inspect any application layer protocols. I didn't inspect UDP. I didn't inspect ICMP. But for TCP, this router is now ready to remember. If we wanted to verify where it was applied, we could just ask it. And to ask it, we can simply do a show IPv6 inspect interfaces, and that will show us exactly where it happens to be applied. And it's going to be applied outbound, shown right here on interface gig 2/0. I think we're ready to go. Let's verify this works. Let's make a road trip over to R1, and we'll just do a real simple telnet session from R1 over to R3. So what should happen is traffic as it goes through R2 should remember that session information, and then the reply traffic from R3 going back to R1, even though there's an access list inbound on gig 2.0 of R2, the inspection will override that and dynamically allow the return traffic. At least that's the theory. Let's take a look and see if it works. So we'll do a telnet to the IP address of R3's gig 2/0 interface. It seems to work, which is great. Let's go ahead and verify that we're on the right device. So this is from R3's perspective. We're telnetted in to R3. We do a who, which is a shortcut for show users, and we're connected to R3 via VTY line 0. And this is our source IP address that we're coming from, which is the IP address of R1. All that looks perfectly great. Let's use one other command that I really like and not a lot of people know about, and that is the command of show control plane host open ports. And this will show us from R3's perspective all the ports that are listening and also establish connections. I just want to verify the ports in use between R1 and R3. And what this indicates is that for this telnet session, R3 sees it as coming in to the well-known port of 23, and the source connection is coming from 2001 DB8 12:1, and the source port is 22,475. That's the one I would have chosen. But the magic I want to share with you is that R2 is tracking this. It knows about the source address and the destination address. It knows about the ports involved, and that's the reason that this session is allowed, return traffic is allowed through R2, is because of the stateful session information. To view that, we can go over to R2 and simply ask R2 to tell us about the details for its stateful remembering of that session. On R2, to do that, we'll simply do a show IPv6 inspect sessions, and that should show us that exact session that's in memory. So this is in effect the stateful information that R2 is remembering that's causing the reply traffic to be allowed back. So here's what happens in the mind of R2. It says, well, if there's any traffic coming from the IP address of R3 on the source port of 23, which is R3 acting as a telnet server, and it's going back to R1's IP address, to the source port that R1 sourced that session from, I'm going to dynamically allow it. And it does that because that's what context-based access control is all about. It's about stateful databases, remembering sessions, and dynamically allowing reply traffic to go back to the individuals who initiated that conversation. In this micronugget, we took a look at the concepts of how context-based access control works, how to configure it, and verify that it's working. I hope this information has been informative for you, and I'd like to thank you for viewing.